What makes a good developer great? This will be a multiple part series where I kind of go over what makes developers that are just okay or good turn into great developers that shape the industry. The first thing I'd like to go over is they understand computer hardware. The big part of that is understanding memory. Most CPUs or just traditional desktops kind of follow this hierarchy where you're going to have your CPU. Your CPU is going to have an L1 and an L2 cache typically, and then there might be an L3 cache that's shared between different cores on the processor, and then you're going to have your main memory, and then you're going to have your disk. But what happens when your CPU makes a load store request, right? If the data needed for compute is not directly within the CPU registers, which is quite common, the CPU will make a request to the L1 cache. If the data is not in the L1 cache, we get what's called a cache miss. We'll go to the L2 cache. If we get a cache miss in L2, then you'll go to potentially L3. Then you'll have a memory controller inside of between this that controls memory accesses to DRAM. What I am going to get into is this idea of burst lengths, specifically a fixed burst length that your memory controller requests when you are requesting memory from DRAM. Typically, this is going to be the size of a cache line in your memory hierarchy. A good length for that would be maybe 64 bytes. So whenever you make a request from DRAM, you're going to be requesting 64 bytes. So these 64 bytes are going to then propagate themselves up through the cache hierarchy and then to the CPU. So let's say we have a for loop. Say this memory is nowhere to be found in my cache hierarchy initially, and I have to go out to main memory to request this data. What will happen on the first cycle is we will stall, we'll get the data back, we'll print out this value, but then other values 2, 3, 4, 5, 6, 7, 8 will be in the cache hierarchy, and we'll get faster lookups after that. This is called spatial locality. It's the concept that data that is close to one another is going to be accessed in times close to each other. And there's another concept called temporal locality, which is when I'm constantly using a piece of data, I want to keep that data inside of my cache hierarchy for faster lookup.